Good afternoon, everybody. Hear me okay? All right, well, my name is McCain, and I work for Mitsubishi Electric Iconics Digital Solutions. So we're part of the Mitsubishi Electric family. We are a North American-based software center of excellence. So for the next 15 to 20 minutes, we're going to take you on a little bit of the journey, and we want this to be thought leadership-centric versus an overt product pitch. We see that there is an emerging need for new tools to help with the complexities that are coming with all of the dynamics in the industry. And we'd like to present that with a little bit of factual information and educate you guys about who we are and what we do. So I'll start with the end in mind. If you'd like to learn more about what we do, we're booth 325, and we'll provide some links towards the end of the presentation so you can learn more about us. All right, so to get us started, I'm going to keep this pretty high level. There are two major themes that we see that are driving complexities in infrastructure management. And unfortunately, due to tariffs, Avril Lavigne was not here to be able to sing a song or jingle, but we got you Mr. Wonderful tomorrow. All right, so I just used all my dad jokes for the entire session, trying to make sure that people are listening, but joking aside, right, back to the script. There's two common themes that we see, one of which, if you've been paying attention to any of these sessions, the first theme is not going to be much of a surprise, and that is the compute technology is advancing much, much faster, at a much greater rate than what has been traditionally the gray-space infrastructure systems that are used to support the compute, the network, and the storage. If I date myself, we might call that, the ICT. All right, so how do we keep up when the reality is you're going to have a combination of old and new workloads in many facilities? The second theme is the increasing data intensity from what has traditionally been gray space assets. And there's a couple of different factors that are driving a need for more data. One of which is regulatory centric. So if we look at the European Energy Directive, and if you're an operating facility above a certain size in Europe, you have new mandates for reporting on energy consumption, water consumption. Eventually that's going to drive CO2 emissions calculations. So you really need high fidelity, granular data that's accessible. Otherwise, it's going to be a very, very manual intensive process to meet those regs. You also have environmental impact reporting requirements from the SEC. So if you're publicly listed in the US, right, you might be thinking about this as part of your corporate sustainability report. What is your IT utilization, particularly if you're outsourcing or you're sourcing certain services from people that ultimately operate data centers. Another obvious scenario is if you're an operator and you provide co-location services, your SLAs are likely getting more and more complex, where you're being required to provide both real-time and historical data on the operating envelope of your tenants' equipment. So how do you do that without building complex and bespoke systems? It becomes pretty kind actually. Now, some of the bigger entities have already solved that problem and they've built custom applications. But here's the rub, and this is kind of like building to our point of view. Making the transformation from a construction project to a production environment, there's a couple of challenges and there's a couple of nuances and some things that get missed. Bank of America Securities published a report back in September 24. They cast a pretty wide net across different types of facilities and different operations, and they calculated the cost per megawatt in 2023 dollars to build facilities with CapEx. And no surprise, the server technology was about 79% of the total CapEx cost. Okay, that's again assuming that we're including that in our factors. You then start to look at the other key gray space assets. Oftentimes, those are things that have long lead times, and we know as an industry, you're looking for things that meet a certain engineering specification, have a fair market price, and have a delivery date. And that ultimately drives things, so you create this domino effect when you're in the construction portions of the facility lifecycle. As you transition to a site that's fully operational, and you're starting to onboard customer equipment and workloads, right, you see this pivot where there's just a disproportionate refresh rate. All right, I'm citing a study that occurred between 2018 and 2020 when we had more traditional CPU type server hardware, but the typical refresh cycle back then was 5 years or less. And you compare and contrast that to the critical facilities assets and the typical depreciation schedules, right? You're running components in the power chain or your primary cooling strategy for decades versus the 3 to 5 year window that you would typically refresh computer hardware. In parallel, you also see that once in production state, depending on the facility type, your annualized OpEx between 40 and 60% is going to be tied to energy utilization. And we know that that's not only for enabling the workloads, but it's also going to be to provide the cooling in the environment. So the point here is, for pennies of investment early on and a little bit of forethought, you really need to have the flexibility to provide a pathway to greater digital maturity as the facility's role evolves and new equipment is brought in. And I couldn't find a better representative example of this concept around maturity for infrastructure management than a recent series of reports from Uptime Intelligence. So the market intelligence part of the Uptime Institute. What they've done is they've really outlined levels of maturity in a manner that is progressive. And if you look at level 1, if you take an OEM approach to construction where you accept the software technology that comes with the key pieces of gray space capital equipment, you end up with islands of configuration and visualization, right? So you may or may not have supervisory control. You may not have consistent alarming and alerting. You may not have consistent data sets. All of those things are really required in order to ultimately reach what is the goal for many, which is, kind of like this level 5 maturity where you're taking advantage of all this contemporary technology and how you run the facility and how you extend the life cycle of critical assets. So I think this is the objective for many. The reality for many, and this is where I go back to a statement I made opening up, where we're casting a very wide net. We saw people that are on the bleeding edge and at the forefront of technical innovation in the keynotes, but we've talked to Fortune 500 companies that run data centers combined with commercial office space and manufacturing on the same campus. They don't even have the ability to calculate PUE today, right? So my point here is thinking about digital maturity, thinking about infrastructure management, there's really 3 key elements that are a solid foundation for you to build towards the future. And those 3 elements are asset connectivity. Can I connect to what's there? Can I expose the data from it? Can I contextualize it in simplified models? Can I provide single-pane-of-glass visualization? Do I have the ability then to make data accessible to an enterprise data strategy, whatever that is, a data estate, a data lake, and then apply advanced analytics tools? It's one thing if you have all of the good detailed design information and you can start off with a multi-physics-based digital twin. The reality, though, is you need to combine those things, if you are that sophisticated of a user, with actual production data, right? And then you truly have a hybrid twin. So going back into the next level of depth on some of the analyst work that Uptime has done, the term DCIM, data center infrastructure management, or data center infrastructure monitoring, it might mean something different to you. The reality is it means different things to different people in the industry. So depending on your organization and possibly even your role, you might use that term different ways. In fact, it might be a bad term because it started getting used about 10 or 15 years ago, and there was this concept of a one-size-fits-all package that encapsulated IT operations, so configuration database management, network management, as well as what have been more traditional facilities or hard FM related connectivity and management. And I go back to what Uptime has come up with recently in terms of thought leadership. They've effectively stated that depending on the organization, you likely need a suite of different tools depending on how you operate and run your business. And for us, our objective is really to focus on, as the title of our session alludes, the gray space, right? The facilities ops related needs for power management, cooling optimization, and visibility and supervisory control of electromechanical systems. And oftentimes this is tied to different outcomes depending on the organizational priority. Clearly there is going to be opportunities for energy optimization and energy savings, right? I mean, think about an existing facility that's going to be retrofitted and that might have some of the brand new liquid cooling direct-to-chip innovation you see on the floor today, but it's sitting right next to the stuff that's running the traditional workloads on the Pizbox servers. I think that that's going to be a reality for a bigger representative number of data centers than some of the brand new hyperscales that have all of the state-of-the-art tech. That's going to happen too, but I think it's going to occur in parallel. So our goal here is really thinking about that asset connectivity, ability to have data, provide single pane of glass, and then provide or serve contextualized data for higher level systems. That also ties directly into optimizing asset reliability and maintenance. It can certainly assist with things like incident response if you have a common alerting strategy. And then business process optimization opportunities are abundant because you likely have traditional computer maintenance management systems, you likely have ticket management systems, you likely have a variety of systems that ultimately need more grace-based data with high fidelity. Getting back to that data intensity statement that I made earlier on. So this is kind of a marketecture example of where Mitsubishi Electric looks to assist data center operators. And again, I don't care what type of facility you run, I don't care if you're a developer who might be taking the facility to a certain state like a powered shell, and then you're looking to either sell the asset or look for a long-term tenant. The reality is you're going to end up with a heterogeneous environment of grace-based assets that are represented in the blocks at the far left-hand side of this slide, right? So if you think about the electrical power chain as a representative example, you likely have a half dozen different suppliers from the revenue grade utility meter all the way to the PDU. There's probably a half dozen different major suppliers in that power chain. If you look at a centralized cooling strategy that might be mechanical and air-based, and then coupling that with in-hall units or like some of the things that are being attached or incorporated into new rack designs, not to mention the direct-to-chip cooling or the full immersion, again, think of all of the different suppliers that are going to end up with really, really sophisticated infrastructure in a building. 90% or more of those assets are going to talk one of three common protocols. So a Modbus variant, SNMP, or perhaps BACnet. We provide really, really strong connectivity, and the goal being we connect with off-the-shelf technology, expose data, and then we create a model that provides a consistent taxonomy for core equipment classes, right? So I'm getting nerdy on you guys right now, talking a little bit of software jargon, but the idea is to create a data model that is consistent regardless of the underlying asset, expose and make data available, have consistency in the way that you apply alarming, have true process historian or time series data for future analysis, and then provide flexible deployment. We know that this is a risk-averse industry. Oftentimes, DSIM and tools that get applied in the gray space, are subject to firewalling or being on local area networks. We support configurations like that. We support configurations where we've monitored edge and modular data centers that are home run back to cloud-based infrastructure that serve NOCs and SOCs. So we've got flexibility in our tools to provide that edge and hybrid deployment. We also have scenarios where we've got very, very large campuses that need to factor in considerations like redundancy and load balancing. And the point here is, with that data model, we enable a single pane of glass output, right? So think about the end user experience, having consistent states, having a consistent data set, having a single source of truth for alarming and alerting. We use that same back-end data model for higher granular reporting on things like energy consumption. So think about a metered PDU and having the detail there so that you want to optimize your contract performance. If you're a colo and you've got tenants that have carved out certain space, being able to slice and dice the power chain differently for the purposes of optimizing and automating your billing process. Think about scenarios where you still need that same level of data for some of the sustainability related calculations and reporting. That's the type of capability that we provide, and again, the flexibility to communicate with the assets that are there today and those that are going to be there in the future. And then the last piece is, and this gets back to like the promise of DSIM 10, 15 years ago, where you would have one tool that does everything, that spanned IT operations to traditional facilities management. The reality is there's a landscape of existing enterprise systems that are out there that are going to do things like your more traditional time-based maintenance. Okay, so can you have data to make more predictive type maintenance strategies? Can you reuse the asset model? Can you reuse the workflows? Can you reuse the ticket creation and status? The answer is yes. What about scenarios that involve ticket management? For those of you that do co-location and you provide, the white glove or the remote hand service for your clients, can you have an integrated experience? The answer is yes. So the point here is the missing piece is the flexibility that I'm describing, because there's this huge amount of focus up front when we're in that construction phase of the life cycle. I've got to get a diesel genset that meets the specification to be delivered on a pad in 18 months, because it's the domino that allows everything else to happen afterwards. And that's fine. And what ultimately those decisions result in is this heterogeneous environment that somebody is going to have to live with later, right? So give them tools ultimately to do their job better, and provide that progressive phase of digital maturity as the organizational readiness improves. So our goal today is to take 15 or 20 minutes, present the industry point of view on why gray-space infrastructure management is so important, and we feel there's a miss in terms of its focus and prioritization today. So we walked you through, how do you start off and access infrastructure maturity? What are some considerations when selecting management tools for flexibility, right? So there's probably not a one-size-all-fit package, and we'll adopt the uptime intelligence lens that, depending on your organization, you probably need to consider a suite of tools. The goal here, though, is to think about some of the rapidly evolving data intensity needs that I described earlier that originate ultimately from gray-space equipment. You got to have that connectivity. And then lastly, when you have the connectivity, the data with context, that really paves a solid foundation for advanced analytics and those higher levels of maturity that were described earlier. With that being said, this isn't really a format to do a whole lot of Q&A. I'd love to talk to you guys. If you see a different, if you have a different perspective and you'd like to share that with us, we're at booth 325. Encourage you to connect on the app, encourage you to connect on LinkedIn. What we have here are two QR codes. One is an industry brochure from Mitsubishi Electric, and then a second is some assets from our partner, ATS Global. We've worked with that organization for well over a decade. They have deployed DSIM solutions in this industry using our technology, addressing the connectivity and the information management challenges that I've described. I'd strongly encourage you, if this resonated with you, to take a look at ATS and to understand how they can help your organization. And then I'll finish by saying, here's my connection information, and hope to see and hear from you all again. That's what I've got today. All right, guys, thanks all so much for spending 15 to 20 minutes with us. Really appreciate it.
I had one.